Welcome to the H2 Laser Controller Board tutorial. This is a high-performance controller designed for small to medium CO2 laser engravers. It features a USB Type-B interface, supports 2-axis XY control, and is fully compatible with Lightburn software. If you are upgrading from the older Shenzhou Yike M2 or M3 boards, the H2 is a direct replacement. On the left is the H2 board, and on the right are the M3 and M3 Plus boards. As you can see, the motherboards are quite similar in size and interface layout. Let's measure the dimensions of the H2 motherboard. Its width is 97 millimeters. The height is 64 millimeters. The mounting hole size is 4.4 millimeters. Next, let's look at the interfaces on the H2 motherboard. This is the interface for the X-axis motor. This is the interface for the Y-axis motor. This is the connector for the laser power supply. The one on the right is the limit switch interface. This is the PWM laser power control interface. Then, let's look at the expansion interfaces. X1 connects to the lid protection or water protection signal. Connecting GND and X1 triggers the alarm. X2 is the motherboard status output interface, 5 volts in standby, 0 volt in operation. X3 is the manual firing function. Connecting GND and X3 emits a laser at 11% power is adjustable. Motherboard interface wiring instructions. First, let's look at the stepper motor interfaces. It supports NEMA 17 stepper motors with a current range of 122A. This is the interface for the X-axis motor. This is the interface for the Y-axis motor. The pin definitions for the motor connectors can be found on the back of the motherboard. If you are unsure about the pinout, simply plug in the motor to test. If it runs smoothly, the wiring sequence is correct. Next, check the movement direction of the X and Y axes. If the direction is inverted, you can adjust it by modifying the motherboard parameters. Please refer to the configuration video for details. If the motor vibrates or fails to move when you control it in the software, it usually indicates an incorrect wiring sequence. Swapping the two middle wires on the connector will likely fix this. Let's watch the demonstration. First, let's observe the motor's behavior with the current wiring. The motor is operating normally. Now, let's swap the two middle wires. After swapping, test the motor movement again. As you can see, the motor vibrates rapidly and fails to move normally. When the motor malfunctions or vibrates, swapping the two middle wires on the connector usually resolves the issue. Swapping the two wires on the same side will reverse the motor's direction. Next, let's look at the motherboard power connector. The pin definitions are labeled on the connector. First, locate the low pin. Connect the motherboard's low pin to the L terminal on the laser power supply. The low pin controls the laser activation. The laser turns on when the signal is low. The NC connector on the motherboard is typically used to connect to the 5 volts terminal on the laser power supply or switching power supply. However, for the H2 motherboard, connecting the NC pin is optional. Since the board has an internal 24 volts to 5 volts converter circuit, it does not require an external 5 volts power source. Regarding the GND and 24 volts connectors on the motherboard, if you are using a laser power supply, connect them to the G and 24 volts terminals. If you are using a switching power supply, connect them to the V and V+ terminals. The pin definitions are also labeled near the laser power interface. The pinout is labeled at the limit switch interface. The default settings support normally closed mechanical switches and NPN inductive switches. If using other types of limit switches, please refer to the table in the user manual to adjust parameters $5 and $7. First, let's look at the mechanical limit switch, which has 3 pins, NC, No, and C. NC stands for normally closed, No for normally open, and C for common. When wiring, connect the C terminal to the motherboard GND. Connect the NC terminal to the ELX or LI interface in normally closed mode, and connect the No terminal to the ELX or LI interface in normally open mode. The motherboard defaults to normally closed NC mechanical limit switches. For wiring, connect the X-axis switch's NC pin to the ELX interface and the C pin to the adjacent GND. Similarly for the Y-axis, connect NC to LI and C to GND. Next, let's test the trigger status. When the switch is pressed, the light burn console immediately reports a limit trigger event. Connect the limit switch to the No terminal and test. If incorrectly connected to the No normally open terminal, the logic will be inverted, triggering on release instead of press, which prevents the machine from homing correctly. For other switch types, please refer to the manual to adjust parameters $5 and $7. This is a common NPN normally closed inductive limit switch. It has 3 wires, brown plus V, blue 0 volt, and black signal output. For wiring, connect the black wire to the ELX or LI interface and the blue wire to the corresponding GND. Regarding the brown wire power, the motherboard's limit interface provides only 5 volts. If your switch supports 5 volts, connect the brown wire directly to the motherboard's 5 volts pin. If your switch requires higher voltage, for example, 12 volts or 24 volts, you must connect the brown wire to an external power source. These are for different types of inductive limit switches, and they all have the same wiring method. Note, the parameters $5 and $7 for inductive switches differ from mechanical ones. Please refer to the configuration video for details. Next is the PWM interface, which controls the laser power. The PWM interface consists of 3 pins, NC, GND, and PWM. For wiring, the NC pin is left unconnected. Connect the motherboard's PWM pin to the laser power supplies in interface and connect the GND pin to the G interface next to it. Next, we will connect the laser control signal wires. First, check the wiring sequence on the motherboard. The yellow wire corresponds to the PWM interface, the black wire corresponds to the GND interface. Then, connect to the laser power supply. Connect the yellow wire to the in port, connect the black wire to the GND port. Next, let's look at another type of laser power supply. As you can see, the in interface on this unit is a terminal block. However, the wiring method is the same. Connect the motherboard's PWM pin to the power supply's in port and the GND pin to the adjacent G port. For your reference, here are the wiring diagrams for 3 common types of laser power supplies. Note, if the laser power supply does not output 24 volts, you must connect the motherboard's 24 volts and GND to an external 24 volts power source. Next is the X1 interface, which is used for safety protection functions. It typically connects to lid protection switches or water flow sensors. The operating logic is as follows. When the X1 interface is disconnected open, the motherboard works normally. When the X1 interface is closed short, the motherboard pauses operation. When disconnected again, the motherboard resumes working. This is a normally closed switch connected to the motherboard's X1 interface. We will use it to simulate the machine's lid open and lid closed status. Now, let's demonstrate the function. When I press the switch simulating the lid being closed, the machine works normally. When I release the switch simulating the lid being opened, the machine pauses immediately. You can also see a door open alert in the Lightburn console. Pressing the switch again resumes the operation. Sending the symbol in the console will retrieve all parameters of the motherboard. The control logic of the X1 interface can be defined by modifying parameter $62. When 62 equals 1 default, triggering the switch pauses the machine. Resetting closing the switch resumes operation automatically. When 62 equals 0, triggering the switch stops the task immediately. Releasing it does not resume operation. Here is how to modify it. Enter the command 62 equals 0 in the console input box and press enter. Then, enter and press enter to list all parameters and verify that $62 has been successfully modified. After the modification, let's test it again. As you can see, when the switch is pressed, the machine works normally. Once I release the switch trigger signal, the machine stops immediately. At this point, even if I press the switch again, the machine does not resume operation. That concludes the demonstration. Please adjust the parameter according to your specific needs. Next is the X2 interface, which acts as the motherboard status signal output. Now, let's watch the demonstration video. When the machine is in standby mode, X2 outputs 5 volts high level. When the machine starts working, X2 drops to 0 volt low level. It is typically used with a relay module to control machine status lights. Finally, let's introduce the X3 interface, which is used for manual laser firing test fire. Shorting the X3 interface activates the laser. The default firing power is 11%, controlled by parameter $47. Now, let's watch the demonstration. The switch is connected to the X3 interface. Turning on the switch shorting the interface successfully fires the laser. You can enter in the console to check the parameters. Find 47 equals 110. Here, 110 represents the S value 11% power, while 1000 represents 100% power. You can adjust this value according to your needs.